This video covers networking basics, which should be understood before going online with Audio Architect. Basic network familiarity and the ability to configure your computer to connect to a network is required to use Audio Architect online to configure and control Harman HiQNet devices. In order to put going online and networking into perspective, we need to take a look at what is called the OSI 7-layer model. The OSI, or Open System Interconnection Model, defines a networking framework for implementing protocols in 7 layers. Control is passed from one layer to the next, starting at the application layer in one station, proceeding to the bottom layer over the channel to the next station and back up the hierarchy. Layer 1 is the physical layer. It's the Cat5e cable or other physical medium. For example, hubs are Layer 1 devices. Besides the audio connection points being wired together, all Harman HiQNet devices in your design must be physically connected to their appropriate network via Cat5e cable plugged into the Ethernet port. This is a physically separate cable set for configuration and control of devices, and a control computer with Audio Architect is also plugged into this network. Layer 2 is the data link layer. Put simply, Layer 2 is Ethernet. Ethernet data is communicated over the network from device to device using Media Access Control, or MAC addresses, to identify each other. AVB and CobraNet traffic are transmitted over Layer 2, also HiQNet protocol control data, the language that Harman devices use to communicate. Switches are Layer 2 devices. Every device and network interface card, which I'll refer to as a NIC for the remainder of this tutorial, has a unique MAC hardware address supplied by the manufacturer and allows devices to uniquely identify themselves on a network. Layer 3 is the network layer where switching and routing technologies reside, creating logical paths for transmitting data from node to node. Addressing is a function of this layer. Internet Protocol, or IP traffic, is communicated over Layer 3, devices identifying themselves with IP addresses. IP data is packetized by the transmitting device for transmission over the Ethernet data link layer and reassembled at the receiving device. Dante is a Layer 3 audio transport, and routers are Layer 3 devices. IP addresses are numbers given to devices represented on a network, similar to a mailing address representing your home's location. All HiQNet devices ship with Dynamic Host Control Protocol, or DHCP, enabled. Provided there is a DHCP server device on the network, you don't have to deal with IP addresses, since HiQNet devices will be given addresses automatically by the DHCP server. If you want to configure the IP addresses of devices manually, the following information will be useful. An IP address is 4 numbers separated by periods, each number being from 0 to 255. The reason for this number range is that these 4 numbers are decimal conversions of 8-digit binary numbers, which have 256 different configurations. This is also why each number is referred to as an octet. Depending on the class of network address being used, the first 2 or 3 octets identify the network, and the last octets identify the individual device node. Each computer knows how to separate the 2 parts of an IP address by using a subnet mask. A subnet mask looks somewhat like an IP address, but it's actually just a filter used to determine which part of an IP address designates the network and which part designates the node. For example, in this Class C IP address, the first 3 octets are reserved for network identity, hence the subnet mask is 255 for those same octets. 1 octet, the last one, is reserved for nodes or devices on the network. These addresses are on the same network, and these addresses are not on the same network. And that's because the first 3 octets that represent the network are different from each other. An important thing to note about IP addresses in a subnet is that the first and last addresses are reserved. The first address identifies the subnet itself, and the last address identifies the broadcast address for systems on that subnet. So make sure that you don't use those 2 numbers when configuring an IP address network. All amps, devices, and the control computer network interface card are configured on the same IP address network to communicate with each other. Layer 4 is the transport layer. Two transport protocols used in Audio Architect sit at layer 4, TCP and UDP. TCP establishes IP connections and ensures delivery of data, while UDP provides transmission without ensuring data delivery. Most high QNet data is TCP, meaning the information is guaranteed to get from point A to point B, although high QNet meter data is transmitted via UDP, since if it's lost, it probably won't matter since all the meter data is in real time. Session layer 5 establishes, manages, and terminates connections. For example, Audio Architect uses port 3804 to communicate high QNet control data to devices on this layer. Layer 6 is the presentation layer and is responsible for converting application data to network data and vice versa. It is highly instrumental in translating between a high QNet software application such as Audio Architect and the communication with devices on the network, for example. Layer 7 is the application layer. Everything at this layer is application specific and provides networking services to software programs such as Audio Architect, Performance Manager, and NetSetter, or email and web applications. There are a lot of considerations outside of Audio Architect with networking that need to be taken care of before pressing the Go Online button in the ribbon. So make sure that they're handled and understood first, especially the IP address network and physical Ethernet cable network. This will eliminate variables for troubleshooting connectivity later when trying to communicate with devices.